In this lecture, we're going to talk about a concept in epidemiology referred to as mortality. And in contrasting mortality and morbidity, when we talk about mortality, we talk about death. When we talk about morbidity, we talk about the development of disease. Specific to mortality, epidemiologists calculate something called mortality rate. And the mortality rate refers to the frequency, how often deaths occur among a particular population. That population has to be clearly defined by the epidemiologist during a specified time interval. And mortality rates are usually adjusted for based upon age, the cause of death, infant mortality, neonatal mortality rate can be adjusted for by race or ethnicity. So the calculation of mortality rate is usually very specific as it goes to as it points to the disease or condition that is being tracked. And mortality rate is just simply calculated as the number of deaths due to a specific disease or disorder divided by the number of people at risk. So the mortality rate does not consider necessarily the number of people that have been affected by that disease, infected, or developed that disease if it's a chronic disease. It just considers in the denominator the number of people at risk. Case fatality rate is a little bit different. The case fatality rate addresses the number of deaths for people who have the condition. So, and that's calculated as the number of deaths due to that disease or disorder divided by the number of people that have the disease or disorder. So the case fatality rate is always going to be greater than the mortality rate because the denominator in the mortality rate calculation is always going to be a larger value than the one for the case fatality rate. Going back to our example of HIV and AIDS in terms of mortality, this is not infection. We can see that from in 1990 in this world map using the color-coded legend here at the bottom of the slide, we see that a number of countries exhibit a wide range of the deaths resulting from HIV/AIDS as a function of the number of people. And so these are the number of deaths per 100,000 people. This is not 100,000 people that have the infection. This is per 100,000 people that are part of the population. So it's important to note that this is mortality, or as the world data indicates here, death rate. And so this is the map in 1990, and the darker shaded regions indicate higher death rates. And we see in the African continent, the countries exhibit the highest levels of mortality due to HIV and AIDS in 1990. And if we jump to 2019 here in the next slide, we see that mortality rate has increased in the Russian Federation. We'll go back one slide here where we see this light shaded area for the Russian Federation, and now we see that the mortality rate due to HIV/AIDS is now a higher value in 2019. And within the African continent, the mortality rate has increased in the southern African continent countries as compared to 1990. If we focus on North America, here we see the mortality rate in the United States was greater in Canada, and we jump to 2019 that although the mortality rate is still higher in the US than it is in Canada, both countries saw a reduction in mortality rate out to 2019. More specific measures of mortality include what's called the proportional mortality rate. And this is a rate that's calculated by relating the deaths from one disorder with respect to deaths of all disorders, hence the term proportional. So one particular condition is of interest to researchers or investigators, and examining how many people have died from that one condition with respect to the other disorders. And proportional mortality rate for one condition can increase over time due to one or combination of the following two factors. The first factor here is that more people are contracting the particular disorder, developing the disorder, and dying from that disorder if the proportional rate increases. If less people are dying from the other disorders that the primary one is being compared to, then that would also contribute to an increase in the proportional mortality rate. And as an example, in Canada, if we examine the leading causes of death in 2019, the four leading causes of death in order were cancer, followed by heart disease, followed by accidents, and then followed by stroke. In 2020, the leading causes of death in Canada included cancer, heart disease, and COVID-19 was number 3 on the list in 2020, pushing accidents to the fourth leading cause of deaths among Canadians in 2020. And so we see here that in terms of proportional mortality rates, more people were contracting COVID-19 and dying as a contributor to that increasing proportion. In terms of the standardized mortality rate, this refers to the ratio of the number of observed deaths from some particular cause, some disease or condition in a given time to the expected number of deaths. And so if this ratio is less than 1, people are dying from the disorder less than expected. And if this is the case, this may be a result of some sort of public health intervention that would mitigate the death of people who contract a particular disease. If the death rate or if the standardized mortality rate is greater than 1.0, then people are dying at a higher than expected rate, and by tracking the standardized mortality rate in a real-time manner as much as possible, this would point to public health agencies to incorporate other types of measures that would bring this ratio back below 1.0. One last measure of mortality rate is termed the crude mortality rate. And the crude mortality rate is one, just as the term suggests, does not adjust the death rate for other causes. But one of the underlying reasons that might account for the crude mortality rate is something called the age pyramid. And an age pyramid is a graphical way to demonstrate the age distribution within a population over a short or long period of time. And that's important to track from a public health perspective, because as people age, the probability of developing conditions and diseases does increase. And so by being able to forecast these age distributions in the future, public health agencies and governments will be able to make changes and put preparations in place in order to be prepared in the future. And so at this point, please link to this YouTube video. It's a very short YouTube video that presents this very interesting graphic in comparing the population period between Canada and Saudi Arabia between 1950 to 2100. And so we have historical data from 1950 out to the present time, and then by using those historical data, the individuals that developed this video were able to extrapolate that pattern, provided that the pattern continues to move in the way that it has from 1950 to the present time out to 2100. So please link to this video and watch this video. It is required viewing to get a sense of how we can compare two different countries in terms of that age pyramid. And by having that underlying understanding, that would be able to enable governments and public health agencies to make those sorts of preparations in the future for aging groups. So please link to the video, and that ends this lecture on mortality rate.